So once you have logged into your Raspberry Pi, go to the terminal and type cd desktop git clone, then type git clone space https://sumit019/miotcode.git and hit enter. So basically what this line of code will do is get you the codes on the desktop, so from my GitHub library. So once you hit enter after writing this stuff, so this will, just a second, this will display a folder in front of your desktop. See, MIOT codes. So basically you go and read this code. There is a readme file in this folder. Read the readme file. So this readme file is telling you to install all these packages that may or may not be installed in your Raspberry Pi. There is a possibility that that might not be there. There is no need to run the git clone code line again. So just run every other line one by one in the terminal. So just Control Z, and you need not to run the git clone again. Close the readme. Once you have completed all these libraries, this will install all the necessary packages and libraries that you will require to run the IoT platform on the Raspberry Pi board. You need not to run anything else. So in my case, I have all the libraries installed in my PC, so I am not running it. So I'm going directly to the code. Just close this GNA. I don't need this one. We need to open the code in Thorny, not in this editor. Open the code in Thorny editor. Just a second. So open the code in Thorny editor. Yeah, so here you must declare all these pins. I have declared this pin according to the kit only. You need not to change anything here. So just go and just change the username and key in the section. These are the old username and keys that I am displaying here right now. The username and key changes with time, so you need to make an account on Adafruit IO, as you have seen in the first video, that is experiment number 4, I guess. Sorry, 4 experiment number 5 of Raspberry Pi interfacing DHT11 or 22. So just go to Adafruit IO. I am using the desktop version because it saves a lot of time to do the work on the desktop rather than on the real hardware. It will take some time and patience when you do it here. You need to create the feeds, direction and speed for this IoT project. So I will delete the feed that I have created before. So just delete this feed and make them again. Basically it is a simple process. This is like you are making a channel or making a variable that travels through the internet and tells the board to change the speed and data, so whichever data the user has sent from the IoT board to the Raspberry Pi board. And we don't need to see this graph. Okay, cut. Yeah, so basically just create these feeds. After creating, go here, there is dashboards. In dashboards you will see the relay one on motors, so we go to motors. So we can see there is nothing here right now. So basically we will create the block again. I guess I had made it. Let me refresh it. I might have to make it again. Maybe it is deleted. So go to dashboard. Okay, let's go to dashboard and create new, or rather I'll just edit this one. Go to the settings once. Let me show you how to create a dashboard if there is not there. So just create a dashboard name motor, and okay, so enter this and go to settings, create new block, select slider switch, give it speed, feed name speed, give it the title of the label that you want on the slider. You can change the value. I am using 0 to 100. This is just enough. And another, I'll use a switch to change the direction of the motor. This is for the DC motor. part. We'll be doing it for the stepper motor also. I am not going to make a separate video. We're going to use the same dashboard. Give direction feed and set label direction or direct accordingly. I'm writing direction here. Set the on 1 on and 0 off value. That is, when the switch is off it will send 0, when the switch is on it will send 1. So basically after this go to the code and you can run it. You just need to make sure that the feed you have entered, that the feed that you have created in the dashboard and in the code are the same. So if you made any changes in that is key, click on save, then click on stop and then click on run. So let's run it. Okay, what is it? Okay, key error. So yeah, as I told before, you need to change the key. My key is one old, so yeah, so here you can see the key, new key. You just need to enter the new key here. Username is the same, I just need to change the key. So let me just do it. Okay, so okay, done. So the key is entered perfectly. Click on save. After this click on save and run. So this should work now. I don't think this should. What is the error now? Okay. We need to go to the dashboard, just change some values. This will initialize the dashboard. As we have just run the code for the first time, you need to change the values, and then this just initiates the dashboard to send values. So now the server is sending values, and here we can see the change in value. Good. So this is for the DC motor. I only have the DC motor, so I'll show you how is the setup part at the end of the video. I have interfaced the DC motor. In the lab there is a stepper motor. You can also use the stepper motor. Here you can see we are able to send the speed value 80 and direction value as 1 and 0 in the form. So let's go to the stepper motor code. It is similar. Yes, I'll have to change the key here again. So okay, this is the code for stepper motor. Need not to change anything here again. Just we need to change the key. You have to put your key. I'll be putting my key, whichever username and key you have to put your own. So I'll just copy paste the key from the previous code. Be easier typing it manually. So okay, done. So once you are done with the key entering part, click on save, and this is the code. Okay, why is terminal on? Okay, yeah, save and then run the code. After saving, save and run. Done. So this should work now. I don't think there should be any errors. Okay, good. Yeah, here the value here is in decimals because I am setting the delay for the switching time of the stepper motor. So basically this slider increases the speed and decreases the speed. That is it. When we increase the slider, we reduce the delay, and when we reduce the slider, we increase the delay. So the stepper will move very slowly, and very slight steps will be there. As the name suggests, it is a stepper motor. It will move only in small steps. So this is it. Let's see the pinout now. So these are the pinouts. You need to connect this accordingly, color coded thing. Also make sure to connect the supply 12 volts. It won't run if you are not connecting the 12 volt through the jumper. There are jumpers available, just ask to okay, here this is my setup. So I have hooked in my Raspberry Pi 4 with a generic motor driver, that is L293D. L293D is a very cost efficient motor driver, control small motors with it. So here I have used a small DC motor and attached a piece of tape in front, so you can see it rotating. Here you can see I have increased the speed, I have decreased a little too much, the motor is stopping. I need to increase it a little more. So once you are comfortable with the speed, you just keep it as it is, and this should do. So this is about the DC motor. The stepper motor will be similar. We have to use the same dashboard for both of them. You need not to make any different dashboard for the stepper motor. Just keep the steps same for stepper motor and DC motor. You just using the feed for the channels. You need not to change anything. Feed as in we are just sending the data of the slider, user data from the slider. We are sliding in the dashboard. This data is sent to the Raspberry Pi. Raspberry Pi will then generate PWM signals and control the stepper and the DC motor accordingly. You need not to worry about this, all this connection. The kit is very modular. So thank you for watching.